Greetings to all the viewers. The session is going to cover the topics related with the intermediate chemistry will be fetching for your international entrance and competitive exams. India is conducting JEE Advanced and JEE means examination will be fetching for your IIT and NIT entrance exam, that is the technical domain. All across India twice a year the exam will be conducted. In addition to this one, NEET exam will be conducted for medical entrance examination. So medical admissions will be possible by NEET exam, uh, attending NEET exam. And next is about Telangana and Andhra Pradesh government are conducting MCET examination to get the admission into BTech stream, where technical domain again. Here, competitive exams will be conducted by various government organizations to get the career opportunities in the various fields, where general studies question paper will be common for all the aspirants. There you can find the general science as the content. General science, the topics what we are covering here can be fetching for all these examinations. Let's enter into our today's session. The Nobel Prize in the Chemistry for the year 2000 was awarded jointly to Alan Heger, Alan G. McDermott, and Hideki Shirakawa for the discovery and development of conducting polymers. So earlier, the perception is plastics are insulators only, better insulators only, but there is a new conception regarding this plastics where the conduction property got introduced. The scientist Alan Heger contributed 1/3 and Alan McDermott also contributed 1/3. Hideki Shirakawa. These three scientists together worked upon this outstanding work where plastics are able to conduct. There is a new kind of research got unveiled by these three scientists together. Hence, for the year 2000, Nobel Prize in the field of chemistry was accorded by Royal Swedish Academy of Sciences to this Ellen J. Heger, University of California, Santa Barbara, United States of America, Alan G. McDermott, University of Pennsylvania, Philadelphia, United States of America, Hideki Shirakawa, University of Tsukuba, Japan, for the discovery and development of conducting polymers. Everybody aware about polymers are nothing but repeated units, very long chains will be there. If that long chains are able to conduct electricity, which are called conductive polymers, that kind of new invention, new research exploration got carried by these three scientists together. Hence, world recognized Nobel Prize is laureated for these three scientists together. Now let's see what was the work carried by these scientists. A plastic that conducts electricity. We have been taught that plastic, unlike metals, do not conduct electricity. Most probably, general characteristic for the plastic we can accord, it is the insulator only. Most of the plastics used as the insulating materials. In fact, plastic is used as an insulator around the copper wires and ordinary electrical cables. Wherever electric cables are available, their insulation that will be surrounded with these plastic materials only. Yet, this year's Nobel Prize laureates in chemistry are being rewarded for their revolutionary discovery. A plastic can, after certain modifications, be made electrically conductive. Right? So, the natural phenomenon for the plastic will be insulation only, but by imbibing some other materials into that, so that structural elevation got carried, which used to convert insulator into the conductive material. Plastics are polymers, molecules that repeat their structure regularly in a long chain. For a polymer to be able to conduct electrical current, it must consist of alternatively single and double bonds. Conduction requires the movement of electrons. In order to pass the electron, the requirement in the organic moieties, most of the polymers are organic utilities only, so that alternative double bond, we can say conjugated double bonds are required. And indeed, they can be doped. The addition of impurities called a doping process, either by oxidation or reduction process, or whenever you're oxidizing them, there is a generation of holes over there, and whenever electrons are released into the system, so that electrons extra added, and the negative charge is originated, so that either by these holes or else electron, they are able to conduct the electricity by the addition of impurities called doping process. Heger, McDonald, and Shirakawa made their similar findings at the end of 1970s and have subsequently developed conductive polymers into a research field of great importance for chemists as well as physicists. The area has also yielded important practical applications. Conductive plastics are used in or being developed industrially for anti-static substances, for photographic film, shields for computer screens against electromagnetic radiation, smart windows that can exclude sunlight. In addition, semiconductive polymers are recently being developed light emitting diodes, solar cells and displays in the mobile telephones and mini format television screens. So many multiple devices got developed because the plastics are used everywhere. Nowadays, we can observe that in so many fields, at household purpose, industrial purpose, academy purpose, wherever you see, there you can find applications for the plastic. So if that plastic is having conductive nature, so that its application point of view got amplified a lot. Multifold applications you can notice, such as anti-static substances and photographic films will be developed. Computer screens against electromagnetic radiation developed. Smart windows will be developed, and semiconducting polymers will be developed. Light emitting diodes, LEDs, and the solar cells also find applications by these conducting polymers. And telephones and mini format television screens, everywhere these kind of conducting polymers are most vital. So whenever a new discovery which is extended for multiple applications, that will be definitely accorded with the prestigious recognition. Research on conductive polymers also closely related with the rapid development in the molecular electronics. In the future, we will be able to produce transistors and other electronic components containing individual molecules, which will dramatically increase the speed and reduce the size of our computers. The computer corresponding to what we know carry around in our bags would suddenly fit inside a watch, right? So already we can experience that earlier the computer monitors and systems are very large in size. Nowadays, because of a new technology invention and rapid involvement of techniques over there, so that its size is concising and applications are increasing by using smaller size of the device and most portable, most convenient to move across wherever we go, so that can be convenient to carry with that particular person, and the most advantageous applications we can find. So that kind of modifications are going to be done. So in the near future, the largest computer will be concised as tiniest as possible to fit into your wrist watch as well. That extent application is also carried by these conducting polymers. Most wide applications we can notice for these conducting polymers. So that 2000 year Nobel Prize is accorded to three scientists together for the discovery and extension of these materials into the various application oriented segments conducting polymers. By this, we can conclude question number 1, entered into question number 2, Cambridge Assessment International Education. The question was collected from. This question is about the halogen and halogen compounds. Deduce the number of electrons, neutrons, and protons of one atom of isotope of chlorine, shown here. Right? So electrons, neutrons, and protons are regarded as subatomic particles. Here, chlorine isotope was provided. Isotope is nothing but with the same atomic number but different differs in their neutron count, which are called isotopes in nature. Chlorine atomic number is given by 17 and atomic mass with 37. It is the isotopic chlorine. From this, you have to go with the calculation of electron count, neutron count, and proton count as well. In order to calculate number of electrons, we have a formula. For the neutral atom, number of protons is equal to number of electrons. They are considered as its atomic number. So that if you observe, here you can find the subscript as 17, superscript as 37. subscript of any atom indicates its atomic number and superscript denotes its atomic mass. So that subscript is 17. 17 denotes what? How many protons are there? In the neutral atom, that exactly is equal to electron count as well. So that let me mention 17 electrons are resided in this chlorine isotope. And if you go with protons, being it is neutral, so that how many electrons, that extent number of protons you can add over. So that proton electron count got completed. Move on to any other subatomic particle called a neutron, being it is neutral. And always it will be calculated by subtracting mass value minus atomic number value. Mass value is given by 37 and atomic number is given by 17. 37, 17 difference is 20. So the 20 neutrons are recorded in this chlorine isotope. This is the way we can go for the calculation of subatomic particles. Hopefully this entire discussion is very clear. By this, we can conclude this question number 2. Let's go with question number 3. Question number 3 collected from 2015 JEE Advanced Question Paper conducted by the National Testing Agency. The correct statement about the chromium plus 2 and manganese plus 3 are: atomic number of chromium is 24, manganese is 25. Chromium is accorded with the plus 2 charge, which is the reducing agent. Manganese plus 3 is the oxidizing agent. Both the chromium plus 2 and manganese plus 3 exhibit D4 electronic configuration. So these are expected to be correct answer, and when chromium plus 2 is used as a reducing agent, chromium ion attains D5 electronic configuration is the wrong one. So let me explain in detail about how can we say A, B, C are correct answer. Chromium plus 2 is a reducing agent because chromium plus 2 is whenever chromium plus 2 is existing, that is of D4 system. D4 system will be there. Whenever D4 system is there, reducing agent in the sense any substance is said to be reducing agent whenever it itself it is oxidizing. Whenever chromium plus 2 is oxidizing, plus 2 will be turned into a plus 3 one. Whenever plus 2 plus 3 conversion is possible, D4 system will be reduced to D3 system. So that a D5 system, they are saying chromium as a reducing agent will rise to D5 is the wrong one. Okay, this is wrong. Then chromium plus 2 is the reducing agent. How can we say chromium plus 2 is ready to release the electron to whoever require over there? So that obviously it is the kind of reducing agent. Most of the metals in general we can say reducing agents only. So nickel, if you observe, rainy nickel is the reducing agent, iron is the reducing agent, cobalt is the reducing. This is the way most of the metals are reducing agents, so that chromium plus 2 is the reducing agent, we can say. Whereas manganese plus 3 is the oxidizing agent. Okay. Manganese plus 3 oxidizing agent. Why we are saying exceptionally manganese plus 3 is the oxidizing agent? Because manganese plus 3 is having a strong tendency to absorb the electron. Whenever electron got absorbed, plus 3 got turned into plus 2. Manganese plus 2 remains more stable because of D5 electronic configuration will be half-filled. Half-filled always highly stable. Everybody aware that half-filled and completely filled are more stable. So that manganese plus 2 is of half-filled configuration. Hence, plus 3 having natural tendency to remove the electron and convert it into plus 2, which is the strong oxidizing agent. This is the way we can clearly explain. And moreover, in plus 3 form, again it is of D4. So whenever D4 is there, obviously D5 tends to convert into D5, right? That's why it is the oxidizing agent. This is the way we can explain. Chromium plus 2 is a reducing agent. Configuration changes from D4 to D3, latter having half-filled T2G level. Whenever D3 got generated in this chromium plus 2, being chromium is having two sets of orbitals, one is T2G and another Eg orbital. That T2G accompanied by 3 electrons, so the T2G level is filled, hence it attains the stability. Though it is losing electron converted into a D3 one, still it is becoming highly stable because of half-filled T2G level. Other hand, a manganese plus 3 to manganese plus 2 results in the half-filled. Half-filled D5 configuration is attained, which is giving extra stability. That's the reason why chromium plus 2 is the reducing and manganese plus 3 is the oxidizing one. Both are accompanied by D4 electronic configuration only. Chromium plus 2 is the reducing, manganese plus 3 is the oxidizing one. So that chromium plus 2, manganese plus 3 both are exhibiting D4 electronic configuration, right? So this is the way we can go with A, B, C are the correct answer for question number 3. Let's go with question number 4. Copper is purified by electrolytic refining in the blister copper. The correct statements about this process is electrolytic refining generally accompanied by the two electrodes and electrolyte and external current should be supplied so that a pure metal will be deposited at the cathodic region. That is the general phenomenon carried. If you go with the copper, blister copper is the kind of impure or crude product of the copper, so that we are applying the electric current that used to generate the purified copper one. In order to get that, let's see what are the correct one. What are the important process carried for the electrolytic refining of blister copper? Always remember, in the electrolytic process, impure metal will be taken as the anodic region. Pure metal will be taken as the cathodic region. Impure copper strip is used as anode, whereas a pure copper method is taken as the cathode. But in the case of option A, impure copper is used as the cathode is the wrong one. Because always a cathode must be pure one. There only deposition of copper by the electrolytic refining process is possible. So pure copper can be taken as the cathode is the correct answer. This is the wrong one. Go with B. Electrolyte used in this acidified aqueous copper sulfate. Being copper extracted, so that copper related electrolyte should be taken. Copper sulfate which dissolved in water is called the aqueous copper sulfate. Acidified means a few drops of acid will be added over. That is taken as the electrolytic solution. So what they mentioned, acidified aqueous copper sulfate used as the electrolyte is the correct one only. Then pure copper deposits as the cathode, obviously correct. Always anodic strip was taken as the impure one. That impure one able to absorb the electrons. When electrons get absorbed, so that ionic copper got turned into a metallic copper. Whenever metallic copper generated called reduction, after the reduction that copper metal generated will be deposited at the cathodic region. This is absolutely correct. Impurities settle as anodic mud. So we are taking impure strip, blister copper strip was taken as an anode, right? Where you can find iron, zinc, nickel, cobalt as a common impurities. So whenever copper slowly moved towards cathodic region, whatever impurities left at anodic region can be deposited at the bottom as the anodic mud. So whatever they are saying impurity settles as anodic mud is correct one only. Only the wrong one among all only copper strip is used as a cathode is wrong. Impure copper always anode. Impure copper taken as a anode, pure copper strip taken as a cathodic one. Except option A, B, C, D are the correct ones only. That are purely explained with this entire clear explanation part. Okay, so B, C, D are the correct options for question number 4. Go with question number 5, which is conducted by Telangana IMSET examination in the year 2020. A gas is present at the pressure of 2 atmosphere. What should be the increase in the pressure so that volume of the gas can be decreased by 1/4 of the initial volume of the constant temperature? This is a question given from the gaseous state where initial pressure is there and volume got changed, so that what will be the effect on that initial volume at a constant temperature. So if pressure got changed, then what will be the volume difference to be understood? ఒక వాయువు 2 అట్మాస్ఫియర్ల పీడనం వద్ద ఉన్నది. దాని ఘనపరిమాణము స్థిర ఉష్ణోగ్రత వద్ద తొలి ఘనపరిమాణంలో 1/4 వంతుకు తగ్గించిన పీడనంలో పెరుగుదల ఎంత? So pressure to be identified, increasing the pressure. So whenever volume decreases, pressure will be increased. Volume is inversely proportional to pressure. That is called Boyle's law. right? So we have to quantify that extent of amount. The expected answer is 8 atmosphere. Pressure is measured in this. Initial pressure is given as 2 atmospheres, so that final pressure also atmospheres we have to go with. 8 atmosphere pressure will be there. Okay, how can we calculate this one? Let's see. PV is equal to constant for the given mass where pressure and V is the volume. So if we go with the equation, two different conditions available. P1 V1 is equal to P2 V2. Initial pressure, initial volume, final pressure, final volume. If you want to calculate the final pressure, P2 is required to be calculated. P1 already given, that is 2 atmospheric pressure. V1 is unknown, that is V meter cube was taken. P2 is required to be calculated. V2 is given by initial volume is concised to 4 times. So that V by 4 we have to mention. So let's put all the values over P1, V1 is equal to P2, V2. So that 2 multiplied with V is equal to P2, that is unknown, P2 into V by 4. So 2 multiplied with V is equal to P2 into V by 4. Then P2 is equal to what happens? 2 into V by V into 4. V by V get cancelled out, 2 into 4. 2 multiplied with 4, that is called 8 atmospheric pressure. So initial pressure is 2 atmospheres, initial volume is V, final volume is V by 4, then final pressure is calculated as 8 atmospheres. So this is the way the problem can be solved. 8 atmospheric pressure is the correct answer for question number 5. Then we are going to conclude with the question number 6. Identify the law. Which of the following statement is true? Equal volume of all gases at same temperature and pressure should contain equal number of molecules. So if the volume is equal for all gases, same temperature present should contain equal number of molecules. Molecules also same. Okay. If volume same at same temperature, then number of molecules also same. ఒకే పీడన ఉష్ణోగ్రత వద్ద సమాన ఘనపరిమాణం గల వాయువులు సమాన అణువులను కలిగి ఉంటాయి. ఈ సూత్రం క్రింది వాటిలో ఏ విధంగా వివరించునో కనుగొనండి. ఓకే, సో హియర్ pressure and temperature kept constant. So if the volumes are equal, then atoms also equal, molecules also equal in number. That is given by Avogadro number. Here Gay-Lussac is there, Avogadro law is there, law of multiple proportions is there, law of conservation of mass is there. We will explain all the laws so that we have to map with which is exactly suitable for the given option, right? So for that purpose, Gay-Lussac law is given. Pressure is directly proportional to temperature. P1 by T1 is equal to P2 by T2. Pressure by temperature is given by constant. The ratio of pressure and temperature is always constant. K is the proportionality constant, which is called Gay-Lussac law. But in this question, they are not mentioned with this pressure and temperature. Here pressure and temperature got constant, so that we are not supposed to apply Avogadro's law. If you go with Avogadro's law, a volume directly proportional to number of moles, number of molecules as well. So that as the volume increases, number of molecules also increases. That only they mentioned here. Equal volume of all gases at the same temperature and pressure should contain equal number of molecules. There is a relation between the volume and the molecules. Volume and the molecules are provided in the Avogadro's law. V is the volume of the gas, N is the number of moles of the gas, K is the constant. So if two conditions are provided, V1 by N1 is equal to V2 by N2. This is Avogadro's law, which is exactly mapping with the statement which you have provided. So option 2 is absolutely correct. Let's go with another two laws as well. Law of multiple proportions. Law of multiple proportions are nothing but here elements can combine with different ways to form different chemical compounds. Though we are having same elements, nitrogen combining with oxygen, either 1:1 ratio is possible or else 1:2 ratio is possible. So 1:1 ratio giving NO as the product. 1:2 ratio is giving NO2 as the product. So here same elements are able to combine in different proportions, so the different chemical compounds will be originated. Mass ratios are simple whole number multiples of each other. Mass ratios are multiples of each other. How many are combining? That extent of mass number will be generated in the product form. So that 1:1 ratio is giving NO, 1:2 ratio is giving NO2. This is called law of multiple proportions. We are not taking in the same ratio. So here elements are same, but ratios are varied. That is called law of multiple proportions. Next is about law of conservation of mass. Let's go with the last one, law of conservation of mass. Mass is neither created nor be destroyed by ordinary chemical and physical changes. Must started and ended with the same amount. How extent we are taking, for example, we are going to burn the logs. So here wooden logs were taken of 30 kgs in our observation. 30 kgs of log were taken. They are supposed to be fired with 1 kg of fire. Even fuel quantity is also measured clearly. 30 kgs of logs and 1 kg of fire together, 31 kgs of starting materials we are going to combine. We are going to burn. Whenever burning is possible, after the complete conversion, after the complete burning of these logs, you can notice some uncombustible ash, and some other matter will be converted into a gaseous smoke. So how much ash is generated by this conversion process? 28 kilograms. 28 kgs of ash is produced at the bottom, and how extent the smoke is evolved? That smoke is of 3 kgs. So that let me add, take the sum of these two, 28 added with the 3, so it will become 31. And if you take the starting material sum, 30 plus 1, 31. So that starting material and final compound composition is not exactly same. Initially it is a wooden log, afterwards it will be ash or else the fumes originated. But law of conservation of mass, we purely focusing on the mass of starting material to mass of product. One of the compound if changed into another compound, but mass will not be destroyed. We are supposed to change one form into another, but not completely destroying the substance. We are not having right to destroy the substance. Just we can convert one of the substance into another form only. That is called law of conservation of mass. The starting material, how much you are taking, that extent of product formation is possible, but in different composition. That is only the possibility we can do. Mass is neither be created nor be destroyed by ordinary chemical and physical reaction, but only the thing is we can change from one form to another form. Right, how much we are taking as a starting material, that extent of product formation is also possible. This is the way law of conservation of mass will be there, but among all the exact law which is suggestible for the given or given equation, the given definition will be Avogadro's law. So by this, we entirely completed the session where various segments of the chemistry got taken into the observation, and authentic learning platforms are taken into the consideration to give the informative session for this topic. And here we covered with the organic chemistry, inorganic, physical, and general chemistry is also taken into the consideration. And I will assure for the compulsory questions from this kind of session, being all these are collected from the previously repeated examination questions, so that this kind of session is really informative who are serious about the examinations. Hence, I'm sincerely requesting you all to like the channel and comment. In order to comment, here is the question for the session. In case of law of conservation of mass, can you put on some more examples related with that one? This is very simple question I am going to ask. Just I would like to check your attention regarding the session what we conducted. Already we gone with the combustion of the log so that ash and fumes are generated. If you go with multiple examples related with that one, you can post here in the comment box for the session. and share with the aspirants who are more curious about the examinations, and subscribe the channel. Definitely we will come up with the new content in the near future and really helpful for your preparation for your whatever goal you have. By this we are going to conclude. Thank you, thanks a lot for your patient listening.